when you're dealing with the matrix, it's the Matrix.
It's the Matrix
movie. I don't know. I've never seen it. I just thought I'd do a reference that might.
Is that relevant to what we're talking about? Like, is that really what a Matrix is?
Yes. I've never seen the movie either, nor have I any interest in seeing it. But all I know is that this is in the movie. It's why I said the Matrix, and I put. I don't know.
It's like a Matrix.
It's a math thing. Anyway, matrices. Here's what we're talking about. Matrices. Basically, a matrix is nothing more than a way of collecting data. It's a way of putting it in a bunch of values, and you're going to be able to do lots of mathematical manipulation with, shall we say. What's nice about matrices is that it really makes chapter 3 stuff very easy. Because I'm here to annoy you, and my job is going well.
Yes. It's like when they did that fraction thing where they equal each other, then they showed us the hard way, and they're like, oh, you can just flip it.
Well, yeah. That's how we roll.
So angry.
That's how we roll. Did you know that? That's why nobody likes their math teachers.
Honestly, I think this is my best class at
Well, air file.
Honestly,
Oh, Mr. Murphy.
Hi, Mr. Hurst.
Mr. Herschel. Mr. Herschel.
That's a C.
Wait, 64%?
He said he got a
You know, like,
You said I got 85.
can't do that.
Cassie's pregnant, y'all. Totally. I found that.
I missed that. How much did I do? 70.
Sorry about that. Anyway, so we're dealing with matrices. I know you guys have all seen this before. You see it with the column, or the brackets, and you got a bunch of entries in these brackets. And the way that you talk about a matrix, matrices are denoted with capital letters. For example, this is matrix A. And when you write them out, we talk about them in terms of their rows and their columns.
Are there commas in between numbers or
No, there are not. So when you're looking at this, this would be considered a 2 by 3 matrix. It has 2 rows and 3 columns. Rows are what go from left to right. You know, row, your row, jumping down the street.
Yeah.
Columns are what hold things up. Easy way to remember that. So your rows, there are 2 rows and there are 3 columns. So they call it a 2 by 3 matrix. There are reasons why we need to know about these are called the dimensions of the matrix. We need to know this in order to do specific operations with them. In order to do any adding or subtracting, you have to have a common dimension. You have a couple different types of matrices. Once again, you have rows and columns. Animation, look at me.
Oh, you're stopping this.
Shout out to Mr. Martin.
Yeah, for real.
Is that you in the boat?
It is. It's a picture of me in the boat.
Dropping on the water jar.
Why do you think like that, Mr. Murphy?
Don't write this stuff down, but what I want to tell you real quick is there are a couple of definitions that you will come across from time to time. You will hear something called a row matrix. It's just a matrix with 1 row. A column matrix is a matrix with 1 column. If you have a square matrix, you will see that quite often. It's a 2 by 2, a 3 by 3, a 4 by 4, and so on and so forth. The rows and columns are equal. What's that? It can be a 1 by 1. Yes. And a 0 matrix is just one with all the zeros as entries. Remember, the values in here, all these numbers, those are called entries. What are they in there? Okay, bless you. One other matrix that you will see in time, probably around section 4, I want to say, so sometime next week, will be something called the identity matrix. The identity matrix is really important because it will allow us to do all of chapter 3 on our calculator.
Come on.
You guys are going to get really, really mad at me. Yeah.
Mr.
No.
Seb did this last
Yeah, he
week.
was
You
like,
need the
oh,
yellow
yeah,
one.
here's the
Yeah.
theory that proves all your proofs.
Yeah,
Yeah.
that's right.
So in order to do basic operations, you have to have what are called common dimensions. Now, if I'm looking at these matrices here, how many rows does this matrix have?
One.
Three.
3 rows, 3 across, 1 column is up and down.
Oh.
So this is a 3 by 1, and what's that?
That is a.
3 by 1.
It's also a 3 by 1. Can I add those two together?
Yeah.
All right, now bear with me. This is going to be really, really difficult. When you add your matrices together, all you're doing is adding or subtracting, if they're common in dimension, the corresponding entries. So, this is going to be tough.
7.
Is that sarcastic tough?
Oh,
It is. What's 3 plus 1?
4.
What's negative 4 and 0?
Negative 4.
7 and 3.
10.
10.
And we've done it.
I.
You never did it.
We have done this in algebra 1, and I still don't understand what is the point of matrices.
Matrices, like I said, we're going to get to the real big why we use matrices probably towards the beginning tomorrow.
Okay.
Because today we're talking about how you do some of the operations and how you do some of the multiplication and scalar stuff and how you can solve some simple equations with them. Tomorrow we'll get into what are called determinants and what's called Cramer's rule. And what that stuff allows you to do is to solve systems of equations. Matrices allow you to solve systems of equations a lot easier than substitution and elimination and all that other things.
Okay.
Okay? That's the main reason of using matrices.
Right.
Are we gonna ever have to use this?
Yes, because I will show you how you do that also, because we will be, like I said, we'll be using these things within word problems as well. It's a very easy way to set up systems. All those word problems we've done, except for linear programming, can all be done via matrix and real fast. So, in B, are those both 2 by 2s?
Yes, they are.
Yeah.
So when I set these things up, obviously your answer is going to be also a 2 by 2. 8 minus 2, 3 minus negative 7, 4 minus 6, 0 minus negative 1. Yeah.
Why did you see it?
Now, in part C, can I add those two together? I cannot because they are not the same dimension. And that's really what you're doing. If you can't do it, you say, no, I can't do it.
That's not what I was told.
You say, impossible.
Isn't it impossible?
Sure.
Like,
Hey, come on now, let's not be too logical.
The other thing that you can talk about here is what we call scalar multiplication. When you're dealing with these things, it's nothing more than the distributive property. And we all know how to distribute, correct? Good. When you're using the distributive property with matrices, you just have to remember to distribute to each and every entry within the matrix. That's all you have to worry about. For example, in this first one, it's 3 times the quantity of the matrix, so your new matrix would look like this: negative 6, 0, 12, and negative 21. It's scalar multiplication. It also works out to be the same idea as order of operations, PEMDAS stuff. You can use, please excuse my dear Aunt Sally, within these style problems as well. In this case here, it's 2 times the quantity of that junk plus that junk. What do you have to do first?
You multiply.
Got to multiply first. So you multiply out, you get a new matrix of negative 2, 4, 0, negative 6, 8, and negative 10. And to that, I have to add that matrix, correct? When you do that, you get a final answer of
A number.
negative 6, a 9, a 6, a negative 14, a 6, and negative 4. Like I said, not so scary, is it? It's just a different way of looking at a collection of data, a collection of numbers, okay? The last part of section 4.1 deals with working in equations with this. Now, once again, it's not going to be anything that's real scary, real difficult to set up and solve, but you just have to be careful about where your entries line up to make sure things match up. Now, in order to solve an equation, you basically have one thing equals something else, correct?
Yeah.
Now, when we're dealing with it in terms of matrices, to have equivalent matrices, you have to have this matrix equal that matrix, right? So what you're doing is you're just setting all the entries equal to each other. And it works out something like this. You guys okay? I see everybody's still kind of looking at this one. You guys all right, or did I screw something up?
No.
All right. So I've never made a mistake. Take a second. Hey,
Jesus.
take a second and write this one out. And this is about as complex as an equation is going to look. Most of them are going to be a lot easier than this. So I figured I'd start with the really, really tough stuff, and then make it simpler easier. Make it simpler later.
Make it simple, easy,
More simple. Not like
Wait, I think so?
Anyway, so here's what happens.
I don't really look at
In order for this stuff to work, we all agree that there's some order of operation stuff going on here. You've got parentheses, and you got stuff inside, and you got stuff outside, right? Now use your order of operations to set it up first. You want with 2 times the matrix of 3x plus 4, negative 1 plus 1, 8 plus negative 2, 5 plus negative y.
Oh, we actually need to add them.
Please excuse my theory.
Ow.
Now what does all this have to equal?
26, 0, 12, 8.
Correct.
So,
Can you give me some room?
why is
Like,
Oh, wow.
like,
How'd you get 10?
Hold on.
like,
What was
like
it?
4x squared, 2x plus 3. Could you put that in the, you know what I mean?
No, I don't. All right. All I did here, guys, is I combined the 2 matrices within the parentheses. Now I've got a scalar on the outside. But remember, in order for this stuff to work, you're basically setting up the following. 2 times this has to equal 26. 2 times 0 has to equal 0. 2 times 6 has to equal,
12.
so 2 times 5 minus y has to equal 8. And that's how you set up those types of equations. What you're doing is you're working your way through the problem to get entry equal entry.
Yes.
And they have to be within the corresponding spots. Because now you just have 3x plus 4 is 13. And then 5 minus what times 2 is 8? What?
Oh, yeah.
Because you divide it by 2, and then 4.
You alright?
10 minus 4 is 9. Yeah.
You have to times it by 2 equals
2
1.
times 5. Why can't equal 2 times 5 is 10. Minus 1 is not 8.
Guys, it's minus 2 times 1.
What's 2 times 1?
1, guys.
What's that?
Okay, so
Times 1.
on the outside,
Yeah.
you still make the 3x plus 4x.
Oh, right here?
Yeah.
Okay. This was the scalar that comes into all 4 of these entries to equal this matrix on the right. So what I did is I just rewrote it as 2 times 3x plus 4 is 26. I just divided both sides by 2 to get 3x plus 4 is 3. I did that first instead of distributing. You can go either way. If you want to distribute and then divide out later, you can do that. When I started doing this stuff, whenever I had something that was that there were both evens on both sides of the equation, and I had that distributive term, I would divide it out just because it was a quicker step. All right. So this is how you wind up with a very simplistic equation via a matrix. Okay? The tricky part here, the most complicated part here, is making sure you keep your entries in order. That's usually where people mess up. I know because that's what I usually screw up. Yeah, don't worry about that now. So let's talk about 4.2.
It was kind of like 7 minutes.
Told you wasn't that much involved to it.
Doesn't matter. There's no X in matrices.
Right. Multiplying matrices. In order to multiply matrices, you have to have something important go on. We have rows times columns, right? That's what they are. The rows times column, the rows by columns in one matrix, say matrix A, and you have rows and columns in the other one, in matrix B. In order to be able to multiply two matrices together, the following has to be held true. The number of columns in the first matrix has to equal the number of rows in the second. If those two values aren't the same, you cannot multiply them together. Okay? Correct. Going from left to right, columns has to equal rows. All right? Now, what happens here is, let's say you have a 2 by 2 and a 2 by 3. They're not the exact same dimensions, are they? No. But do the number of columns in the first one match the number of rows in the second?
Yeah.
Yes. So since these two values are the same, when you multiply those together, the result matrix is going to be a 2 by 3.
That's so weird.
Okay? The result matrix, when you multiply it out, will be 2 by 3. These are equal. This is the new. Okay? And it's a little bit of a weird process as we get into this, how that occurs. Today, what we're going to kind of work on is just square matrices. 2 by 2, 3 by 3. Just very simple stuff to start with. But what I'm telling you here is, in order to be able to multiply, the number of columns in the first has to equal the number of rows in the second. If it doesn't, it won't work. Does that make sense?
So if that was a 2 by 4, then it would just be 2 by 4 that we would
If it was, all right, so if the first one is 2 by 4, what's the second one? All right, the second one is 2 by 3. Can I multiply them? No. So you can't do it.
What if it was a 4 by 2?
If it was a 2 by 4 and a 4 by 2, can I multiply them?
Yeah.
Yes. What's my result matrix? Correct.
Wait, what was the result matrix?
If it was 2 by 4 and a 4 by 2, are those two numbers the same?
Yeah.
Okay, what are these? It's 2 by 2 then.
What if it was
What's the like reasoning behind it?
Rows and columns. The way that you multiply things out, the way that the rows to columns, it has a specific pattern that occurs. And I haven't shown you what that looks like yet. It takes, this is the goofy stuff here. Yes, sir?
If it's 2 by 4 and 3 by 2,
2 by 4 and 3 by 2. Are these two numbers the same?
yeah, but what if you put that one in front then, since it's multiplication?
Okay, but here's the thing. When you're talking about matrix A times matrix B, if this is A, this is B. A times B cannot occur, but matrix B times matrix A can. And that's where it gets dicey with matrices. You have to be very careful in what direction. Because multiplying, we always think, 2 times 3 is 6, 3 times 2 is 6. Multiplication of matrices is not commutative. Okay? It's not a commutative property. You can distribute, you can do all other stuff on there, but you have to follow the letters specifically. Yes?
What if they were both 2 by 4?
If they're both 2 by 4s, do they match up in the middle?
No.
Then you can't do it. Yeah, you can go 2 by 4, 4 by 2, but you can't go 2 by 4, 2 by 4, because the 4 and the 2 are not the same. Okay? Let me show you what this looks like. Yes, sir? Shh, guys. Yeah. Impossible, can't do it. So here's what happens. Let's take a look at this multiplication problem. The two matrices that I have here are 3, 2, negative 1, 0, 1, negative 4, 2, 1. Do you agree?
Yeah.
What are the dimensions of both of them? All right, so these are both 2 by 2. These numbers are the same. So my result will be, this is going to equal a 2 by 2 when I'm done, right? 2 rows, 2 columns. So what I want to be able to do here is I use this following shortcut, if you will, to do my multiplication. Now, I know that I'm going to have 2 columns here. Do you agree? So when I go to solve this problem, the way that I start this is that I start by writing out the first matrix twice. Let me show you how this looks. Let me kind of redo this.
It's just multiply
Nope.
Was
That doesn't
that
work.
a 9 before though? That's 0.
No, it's a 0. Do you see how I just wrote down, I rewrote this matrix here, here, and here. All I did was rewrote those 4 entries into 2 different columns. Okay? Because I know that the result matrix is going to have 2 columns. So if I know the result matrix is going to have 2 columns, that's the number of times I write down the first matrix. If it has 3 columns, how many times do I write that down? If it has 1, how many times do I write it down? 1, okay? And so on. So since I know that I'm going to have a 2 by 2, 2 rows, 2 columns, I write down that first matrix twice. Now, with the multiplication, this is where things get a little weird. What you do is you take that second matrix now. You start in the upper left-hand corner with the first entry. It's a 1. And I'm going to create a column of 1s. There. I go to the next number in that column, 2. I ran out of numbers. I go to the next. I go to the next. What happens is that you follow this same pattern. You start at the top left, work your way down, go back up, work your way down, and so on and so forth. So if there were more rows here, this would have to have more rows. I would just continue to fill in 1s. So it just goes 1. You're putting those in that order. You do a couple of these, the pattern starts to evolve itself. Yes, ma'am?
What if it was a low? What if you only had write it once?
Then you just write it once. And that, we'll see those specifics later. Today we're just working with square matrices, 2 by 2s, 3 by 3s. We'll get into the weird dimension stuff later. Okay? Now, all we have to do is some simple arithmetic. 3 times 1 plus 2 times 2 is what? 7. Negative 1 plus 0. Negative 12. Oh, excuse me. Yeah, negative 12 plus 2. 4, bless you, plus 0. And there's my answer. My answer, remember, 2 by 2 times 2 by 2 is going to give me a 2 by 2.
So when you're writing the numbers with parentheses, it's always going to be like the top left and the bottom.
Yeah.
Okay.
Where did you add it again? Oh, never mind.
Okay? And like I said, this is a very weird thing to see to start with, because you've never seen this before. All right? You always start by figuring out the number of columns you're going to wind up with in your result, and then you just work your way through it. Okay? Let me show you another one. Are we okay with this one, or can I go to another one? All right. In this one, we have negative 6, negative 2, 0, 3 times negative 1, 4, negative 5, 3. Let you write that up. What will the result matrix be in this case? 2 by 2. So it's going to have how many columns?
2.
How many times do I need to write down that first matrix?
2.
Okay, so we start with that. -6, 0, -2, 3, -6, 0, 2, nope, -2. Okay? Now I just fill in the columns. Upper left, -1. And 3 and 3. And you wind up with a handful of very easy multiplication dishes-offs. The trick here is to always start by figuring out how many columns you have, and that's how many times you write down that first matrix. From there, it's just a matter of filling in the blanks and remembering what direction you're writing your columns in, okay? So now it's filling in the blanks. 6 plus 10. Everybody jump at once. 0 plus -15. -24 and -6.
That was not me. That was him.
You want to play the tape back?
Yes, 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 I do. As a matter of fact, I do. I
I'm
love
busy.
this.
Now, you're probably all going, well, how do I know if I was right when I did all this stuff, Murphy? Take out the brick. Like I said, there will be times you will be able to use your calculator, there will be times you will not be able to use your calculator. In this case right now, I will tell you how to use your calculator to see if you are correct, because you've never done this before. In your calculator, there is a button.
There are a lot of them.
There's a lot of buttons. But there's one that says matrix.
I see it. I pressed it.
Hit second matrix. If you don't have a yellow calculator, you don't have that button. All right. Now, what you want to do here is you notice that there's a whole bunch of different matrices. What we have to do is edit them. And I'm going to move it over to where it says edit. And I hit enter to go into matrix A. Right now, matrix A is set up as a generic 1 by 1. We're not working with 1 by 1, we're working with a 2 by 2, right?
Yeah.
So you type in 2, enter 2. And all of a sudden, you'll see a 2 by 2 matrix on your screen. This is great, especially for those of us that forget if it's a 3 by 2 or if it's a 2 by 3, if you're not sure which one goes with what. You can always go back in your calculator and double check. Is it a 2 by 3? It'll visually show you what a 2 by 3 looks like. It'll visually show you what a 3 by 2 looks like. So you know if it's going lengthwise or heightwise with those things. You'll never get that wrong. What were our entries? We had, let's put matrix A as -6, -2. So when we type it in, just hit -6, enter, -2, enter. And when you type it into the calculator, it goes from left to right, like you would be reading. And right now I've entered in everything for matrix A. Quit, get out of it. Second mode. It's painstakingly, takes forever to enter matrices in your calculator. Go back in, create matrix B. The second matrix, scroll down one spot to B, and you want to edit again. And once again, we're going to create matrix B as a 2 by 2. What were the numbers here? I'm kind of on the screen is in the way here.
-1.
-1, 4, -5.
-1, 4. Back out one more time. It's very exciting.
Look at all those buttons.
Now, we need to multiply matrix A times matrix B. Oops, wrong one. Matrix. Go back to matrix A, hit enter. Second matrix, scroll down to matrix B, hit enter. These two things should be on your screen like that now. When you put them next to one another like that, it is implying within the calculator that they are correct. Hit enter.
Why would you do it by hand? Yes, I go to use my calculator.
Because you have to still know how to do it by hand. Like I said, I'm gonna have you do some of these by hands and some of these by calculator.
So like, if I don't have that calculator, can I do it all by hand?
So much.
Sure.
Even if you say calculator, I can do it, you won't mark off points?
We don't need more points.
No, I said you won't mark
It's almost
off.
lunchtime
Like,
yet,
if you say
like,
solve it with calculator, and just put the answer, can I do it by hand?
You wanna make sure you get that calculator.
It's easier.
Where's your calculator?
I didn't get it.
Why do you get a calculator?
No, he doesn't have it right now.
Because you don't, didn't I check you out one? Why? I told you you needed, I'll have to get one. We're all out of calculators. We don't have any. Great. All right. So anyway, this is a great way to be able to check your work. Bless you. Okay. Now, as we go further along into these things, you will find out that solving matrices and working them out, as you go 2 by 2s, pretty easy. 3 by 3s get a little bit more tedious by hand, but as we get further along, we'll start using calculators a little bit more and more and more here. So what I have for tonight is a couple of problems mixed in with between the two sections. On 4.1 was page something. Oh wait, it's right here.
They're not bad. Do you want us to do them by hand or with the calculator?
These first two are by hand because I'm just giving you two by 2s. And it's on page, I think it's 211. And it's number 19 and 20 if I'm not mistaken.
Just the first two are by hand?
Today, everything's being done by hand.
So our homework was 203, 255, and
Yeah, it's covering 2 sections. The reason I gave you the odd numbers in that first section is that way you can double check, make sure you got your answers right. And yes, it is 19 and 20. And then number 19 and number 20 here are also just multiplying 2 by 2s. Do it all by hand tonight, okay? Try and get all that done by hand. There's a couple of equations built into there. Tomorrow what we'll do, we'll take this even a step further. We'll work with determinants, Kramer's rule, solve areas of triangles, things like that.
Kramer's rule good.
This is 4.1, this is 4.2. Okay?
She brought it. And then it comes better again.